Everyone, my name is Luna, and today I'm going to present about the topic analysis of MLOps pipeline in terms of their purpose and contributions. Here's my table of contents. I'm going to have an introduction and an explanation and rationale, and analysis and reflection, and finally a quick conclusion of this presentation. So first of all, I'll start by introducing MLOps pipeline. So first of all, what is MLOps? So MLOps is a collaborative function often consisting of data scientists, machine learning engineers, and DevOps engineers. So the pipeline is a very general term, but overall, the majority of the literature use the term pipeline or machine learning operations pipeline to indicate the coordination and automation of all steps involved in a machine learning process. As you can imagine, these steps include data preparation and validation, model training, testing, and deployment, and etc. The scope of machine learning operations pipeline. A pipeline is a process that combines different modules in machine learning process. These modules are not fixed. Therefore, in my opinion, the scope of a MLOps pipeline is not fixed. It is determined by the purpose of the pipeline, but the overall scope should cover the entire machine learning process starting from data processing all the way to the end. And for sure, the scope also covers the machine learning modules in between, such as algorithms building, evaluation, and deployment. Generally, a complete machine learning pipeline scope usually includes the following. 1. Version the data effectively and kick off a new model training run. 2. Validate the received data and check against the data draft. 3. Efficiently pre-process data for model training and validation. 4. Effectively train machine learning models. 5. Track model training. 6. Analyze and validate trained and trained models. 7. Deployed the validated model. 8. Scale the deployed model. And lastly, capture new training data and model performance metrics with feedback loops. So main components of an MLOps pipeline. The complete development pipeline includes 3 essential components. So there are basically 3 pipelines: data pipeline, machine learning model pipeline, and application pipeline. So first of all, data pre-processing is the first main component. It is highly likely that you cannot use your freshly collected data and train your machine learning model directly. So in almost all cases, you will need to pre-process the data to use it for your training runs. Labels often need to be converted to one or multi-hot vectors. The same applies to the model inputs. If you train a model from text data, you want to convert the characters of the text to indices or the text tokens toward vectors. Next step or next main component is data pre-processing tools can range from a simple Python script to elaborate graph models. While most data scientists focus on the processing capabilities of their preferred tools, it is also important that modifications of pre-processing steps can be linked to the processed data and vice versa. This means if someone modifies a processing steps, the previous training data should also become invalid and force an update of the entire pipeline. The next main component is the model training and tuning. The model training step is the core of the machine learning pipeline. In this step, we train a model to take inputs and predict an output with the lowest error possible. With large models, and especially with large training sets, this step can quickly become difficult to manage. Since memory is generally a finite resource for our computations, the efficient distribution of the model training is crucial. The next main component is the module analysis. So generally, we would use accuracy or loss to determine the optimal set of model parameters. But once we have settled on the final version of the model, it is extremely useful to carry out a more in-depth analysis of the model's performance. This may include calculating other metrics such as precision, recall, or AUC, or area under the curve, or calculating the performance on a larger data set than the validation set used in the training. Another reason for an in-depth model analysis is to check that the model's predictions are fair. It is impossible to tell how the model will perform for different groups of users unless the dataset is sliced and the performance is calculated for each slice. The next main component is model versioning. So the purpose of the model versioning and validation step is to keep track of which model set of hyperparameters and datasets have been selected as the next version to be deployed. And the next main component is the model deployment. So once you have trained, turned, and analyzed the model, it is ready for prime time. And the last main component is feedback loops. So the last step of the machine learning pipeline is often forgotten, but it is crucial to the success of data science projects. We need to close the loop. We can then measure the effectiveness and performance of the newly deployed model. During this step, we can capture valuable information about the performance of the model. In some situations, we can also capture new training data to increase our datasets and update our model. So I want to show another example to better explain components of MLOps pipeline. This figure uses Kubeflow pipelines with SageMaker components that will probably provide a better illustration. So Kubeflow pipelines is a component in Kubeflow that manages and orchestrates the end-to-end ML workflows. The pipeline is composed of individual steps. Each step is an execution of a component. The component is implemented as a Docker container. It contains obviously the code to execute and also any inputs and outputs and the metadata for the specific step. So when creating a pipeline, we're basically lining up these individual steps to define the Kubeflow pipeline. Then we will introduce Amazon SageMaker to the Kubeflow pipeline. When you introduce SageMaker components, what changes is that each of the steps having the logic being executed on Amazon SageMaker. So there is a component container that will taking the description, like the job description, say it's a training job or parameter hyper optimization job, module hosting endpoints, influence endpoints, and so on. And then it forwards the request to Amazon SageMaker, and SageMaker will do that particular step, but it's part of the Kubeflow pipeline, so it's still manageable. So where does MLOps pipeline fit in the MLOps maturity model? The MLOps maturity model helps to show you how to grow the MLOps capability in increments. So there are basically 5 levels. At level 0, you have no MLOps. Definitely you have no pipeline. At level 1 and level 2, you have data pipeline gathers data automatically. So you have data pipeline here. At level 3 and level 4, you not only have data pipeline gathers data automatically, but you also have release managed by continuous delivery pipeline. Main benefits of the MLOps pipeline. So in the next 2 slides, I'm going to talk about the main benefits of MLOps pipeline. So first of all is definitely automation. So after data scientists and system integrators collected and cleaned up data, they had to manually create, validate, and deploy the model. These actions could mislead to errors and lead to overrun in operational costs. To truly create efficiency in operational tasks, training and deployment pipelines needs to be automated. Automation can benefit data scientists to focus on what they do best by eliminating the needs of manual intervention. The next benefit is reusability. So a pipeline contains a number of machine learning modules. In some sense, we can say that the steps in a pipeline are separated from the pipeline itself. So that, the machine learning modules in one pipeline can be used in other pipelines. One single step in a pipeline can be used elsewhere repeatedly. And the next benefit is repeatability. So in a machine learning pipeline, any data scientists or machine learning engineer can restart the pipeline manually so that it will be clear which order the code, script, or notebook will run. The next main benefit is the flexibility. So the steps in MLOps, such as data preparation, model training, and model verification deployment in a pipeline are independent so that we can use different steps in different environments. Some other main benefits about MLOps pipeline. The first one is ability to focus on new models. That is kind of similar as the automation that I talked about on last slide. And the next is prevention of bugs. So automated pipelines can prevent bugs. Newly created models will be tied to a set of versioned data, and pre-processing steps will be tied to the developed model. So this means that if new data is collected, a new model will be generated. If the pre-processing steps are updated, the training data will become invalid and a new model will be generated. So imagine in manual machine learning workflows, a common source of bug is the change in the pre-processing step after a model was trained. In this case, with pipelines, we will deploy a model with different processing instructions than what we trained the model with. With automated workflows, these errors can be prevented. The next main benefit is a useful paper trail. So experiment tracking and the model release management generate a paper trail of the model change. The experiment will record changes to the model's hyperparameters. It uses datasets and the resulting model metrics, such as loss or accuracy. The model release management will keep track of which model was ultimately selected and deployed. This paper trail is especially valuable if the data science team needs to recreate a model or track the model's performance. The last main benefit I put here is standardization. So standardized machine learning pipelines improves the experience of a data science team. Due to the standardized setups, data scientists can be onboarded quickly or move across teams and find the same development environment. This improves efficiency and reduces the time spent getting set up on a new project. The time investment of setting up machine learning pipelines can also lead to an improved retention rate. There are both financial and non-financial costs that comes with MLOps pipeline. In a research paper called Who Needs MLOps? What data scientists seek to accomplish and how can MLOps help? The authors noted the various costs associated with machine learning in general, and some of these apply to machine learning operations pipelines as well. So as a result, the key challenges that the companies they surveyed identified in the context of machine learning are visualized in this figure. So if you look at row I, it's a difficulty of collaboration or collaborating to achieve consensus. Of course, MLOps requires groups to work together, but it's challenging right now. If you look at row D, the survey, they responded not enough data scientists or not enough technical expertise. So MLOps requires specialized talent, but this is kind of challenging right now. If you look at row F, not enough budget for purposes. So not enough budget for purposes such as solutions and computing. MLOps definitely requires financial investment, and this can be challenging sometimes, or it is a cost sometimes. If you look at row B, it's unclear or unrealistic expectations. So MLOps needs clear targets for sure. This comes as a cost. How to assess MLOps pipeline? So the things we're gonna look at when assessing MLOps pipeline includes general business related stuff such as pricing, security, and the product support. And then we're looking at setup, so like how much infrastructure is needed, how easy it is to plug into the workflow. And then we'll look at the system's flexibility, speed, and accessibility. Like, can you customize the metadata structure? Is this accessible from your language framework or infrastructure? Is it fast and reliable enough for your workflow? And the next thing we're going to look at is the model versioning, lineage, and packaging. So can your version and reproduce models and experiment? Can you see complete model lineage with data models experiments used downstream? Next, we're looking at our like logs and display of metadata. So what metadata types are supported in the API or UI? Can you render audio or video? What do you get out of the box for the framework? The next thing we're looking at is comparing and visualizing experiments and models. So like what visualizations are supported? Does it have parallel coordinate plots? Can we compare images? Can we debug system information? The next thing is model review, collaboration, sharing. So like, can we approve models automatically and manually before moving to production? Can we comment and discuss experiments with my team? Other things we're looking at when assessing a MLOps pipeline, including CI, CD, CT compatibility. So how well does it work with CI/CD tools? Does it support continuous training, testing, or CT? The last thing I could think about is integrations and support. So does it integrate with my model training frameworks? For the next 2 slides, I'm going to talk about the capabilities offered in AWS Cloud for machine learning operations pipeline. These capabilities are screenshots that were taken directly from AWS website. As you can see, its capabilities includes training, like algorithms, hyperparameter training jobs, augmented AI, inference, and notebooks such as notebook instances. And here, now I want to talk about what is possible within AWS for machine learning operations pipeline purposes. The first thing I'm going to talk about is the data pre-processing AWS. So in AWS, you can utilize Jupyter Notebook, SageMaker's scikit-learn container, or you can create your own pre-processing code using script processor when you're doing data pre-processing AWS. The next thing is that you can build and deploy models in SageMaker. And next thing you can achieve is to use CloudWatch with SageMaker. So Amazon CloudWatch is a service provided by Amazon that tracks the resource activities of AWS and provides metrics related to it. It also stores the logs that are provided by every resource used. Through these logs and metrics, a user can explore the performance of an AWS resource being used and what can be done to improve it. So when it comes to machine learning, especially with SageMaker, CloudWatch logs gives you the output of containers in which the code is running, so it is pretty useful sometimes. And the next thing is running a custom algorithm in SageMaker. So although SageMaker provides built-in algorithms for almost any kinds of problem statement, many times we want to run our own customer model utilizing the power of SageMaker. The last thing is definitely we can make an end-to-end pipeline in SageMaker. So we can use a combination of AWS services to automate the entire process of machine learning. So how can MLOps pipelines be created? For the next couple of slides, I'll show you how to build an end-to-end MLOps pipeline. So to create a pipeline, we'll start by ingesting the data, and this happens in data pipeline step. there are a couple of steps to perform in data pipeline step. Data analysis, data transformation, data validation, and creating training data before starting developing the model. The model development process, including developing model training code, model validation, and training. And the last step following this is the model deployment and monitoring. Going back to the Kubeflow pipeline overview, we can see the process is very modular. The key thing I want to mention here is to focus on the input and output. So every step consumes something from the previous step and produces something for the next step to consume. Overall, the steps for creating a MLOps pipeline by using Amazon SageMaker components involves 4 steps. First of all, importing Kubeflow pipelines. Then you would load SageMaker components located in GitHub, and then prepare the training datasets, and then creating the pipeline using code. Opportunities related to improving MLOps pipeline. For sure, there are definitely areas of improvement for SageMaker or AWS Cloud in general. So a research paper by Joe and colleagues investigated the computing resources utilization information during the execution of Kubeflow pipelines. So as shown in the figure, the average GPU utilization rate, which is shown in the red bar, is all between 89% to 98% with little distinction, even though when we are training different models. So on the horizontal row is like different models. So this means there's a high utilization of GPU. High utilization not only means being able to make full use of GPU, but also means that program will compete for GPU usage when executing multiple model training tasks simultaneously. So this also brings a problem for machine learning platform providers, which is how to improve memory and frame buffer memory utilization when GPU usage reaches a bottleneck. This figure, so another area of improvement is the time consumption of the CI/CD pipelines. So this figure comes from the same journal article. The author shows the average time consumption of CI/CD steps separately calculated. Among the total time consumed by CI/CD pipeline execution, the Kubeflow pipeline packaging step accounts for the largest part, followed by the steps that uploads files and sets Kubeflow pipelines to run. Each pipeline packaging step took about 10 to 21 seconds, which is quite a lot of time. So it takes relatively long time to compile the Kubeflow pipeline Python files into YAML format using the SDK. Besides this, uploading files to Kubeflow took more time than downloading files from Git repositories, when it was completed in 8.5 seconds to 15 seconds. So this is the timing, the speed should definitely be another area of improvement. Finally, I would like to mention, even though I haven't put it onto the slides, is that some concerns that often come up with considering a move to the cloud, such as downtime, security, privacy, limited control, and backup protection. These are also some other considerations besides, technical considerations. Here's a quick summary of my presentation. So MLOps pipelines generally consist of multiple steps, a modular process, and coordinates the flow of training data, as well as the generation and delivery of trained machine learning models. The scope of MLOps pipeline covers the end-to-end machine learning process depending on the need. MLOps pipeline offers a diverse range of advantages, including automation, reusability, ability to focus on new model, prevention of bugs, and standardization. Use of MLOps comes with financial and non-financial costs. Area of improvement for Amazon SageMaker, GPU resource consumption, and time consumption of packaging step in CI/CD pipeline execution. That's the end of my presentation. Thank you so much for watching.